How are you, my friends? This is lecture number 4 from the Calculus 1 lectures, more about limits. In the objectives of this lecture, we see the basic trigonometric limit, the squeeze law of limits, one-sided limits of functions, and the infinite limits of functions. So we start with the basic trigonometric limit. One of the most important rules in limits, we say the limit of sine x divided by x as x goes to 0 is equal to 1. This is very, very important. You can look at the graph of this function, sine x over x. We will graph many functions later in this course. And you can see here the function is not defined at 0. So there is a hole here because x cannot be 0. But the limit as x goes to 0, it is always 1. Sine x divided by x. Remember that. Now let's look at a nice example here. Find the limit, if it exists, the limit of 1 minus cosine x divided by x as x goes to 0. Let's see, we start as usual by substitution first. So we can write 1 minus cosine x, which is 1 minus cosine of 0 over 0. Cosine of 0 is 1. 1 minus 1, 0 over 0. Okay, so from here we cannot conclude what is the limit. So something should be done. Let's take now the expression here, 1 minus cosine of x divided by x. Let's multiply up and down by the conjugate because we need to change the form of the question, 1 minus cosine x all divided by x. If you multiply in the numerator, this is the difference between two squares. So that's 1 minus cosine squared of x. Here we leave x in the bracket, we put 1 plus cosine of x. 1 minus cosine squared of x will be sine squared of x. Now I can split it here. I can take sine of x divided by x separate and make a product here, sine x divided by 1 plus cosine of the x. Then I can use substitution here. We know this is the basic trig limit here. So that's 1. And this one, sine of 0 is 0, 1 is there, cosine of 0 also 1, 1 plus 1, 2, 0 over 2, 0 times the 1. So the limit here is 0, so it exists. Now, what is the squeeze law of limits? Squeeze law, when we have a function g squeezed between two functions here, we have function h, function f, and function g is between them. So we say g of x is greater than f of x, less than g h of x. Now, if we know the limit of the function f and the limit of the function h, and they are equal, since g between them, so we can conclude the limit of the g of x as x goes to a is equal to L. So we call this squeeze law. In some books, you can say this the name sandwich theorem, which is the same idea, but different wording. Squeeze law and sandwich theorem. Use the squeeze law to find the limit x sine 1 over x as x goes to 0. How can we do that to check the limit? Now, we know this is absolute value inequality. If absolute value of k is less than or equal to b, then k between minus b and b. Remember this from algebra. Now, the range of any sine function, so if we have this function, sine 1 over x, the range between minus 1 and 1, we know that. Then we can write this as absolute value. It will be absolute value of sine 1 over x less than or equal to 1. We can use that rule here up. Then multiply now on both sides positive number, which is absolute value of x. Multiply both sides with the positive number. So this becomes here absolute value times absolute value, when one absolute value less than this absolute value. If we have an absolute value of something less than another absolute value, we can write this one here between minus absolute value of x and absolute value of x. Now let's call this function f. In the middle, we call it function g, which is the given. And here we call it function h. Now this is absolute value function, the limit of minus absolute value of x, the same as the limit of absolute value of x as x goes to 0. It will be 0 because that's a V shape in the graph. So we conclude the function g by squeeze law in the middle. It will be the limit of all this as x goes to 0 will be also 0. One-sided limits of function. We can define the limit from the right. So we say the limit of f of x as x goes to a positive. Here we write plus on the top of a. We say the limit of f of x as x goes to a from the right is equal to L. So this is one-sided limit. Let's look at this function here, f of x, x over absolute value of x. It will be minus 1 if x is less than 0, 1 if x is greater than 0. If we look the limit from the right side, so the limit of the function f of x, the limit of x over absolute value of x as x goes to 0, from the right side, it will be the plus 1 here, plus 1 there, because we are coming from the right. See, a plus coming from the right. Same thing here, the limit of the function f, if x goes to a from the left, so we are coming this way. We are coming to a from the left. So here the limit also is L. Sometimes both are the same or different. If they are different, we say the limit does not exist. Total limit does not exist. So the limit of x divided by absolute value of x, if we take this same function, if x goes to 0 from the left, because there's a minus here, it will be minus 1. Now this is what I was saying, one-sided and two-sided limits. So the limit of the function x goes to a exists. It is equal to L if both limits exist and they are the same number L from the right and from the left. They should be equal. Now let's take an example about greatest integer function. You know the greatest integer function we have seen in the algebra course. F of x is equal to greatest integer function. Let's find the limit of the greatest integer function as x goes to a if a is an integer. Let's look at the graph here. I put the graph here. A is an integer, so it might be 1 or 2 or 3 or 4. Now in the next example, we will take a just a real number like 2.1 or 3.4 or 4.5 or 0.6, not integer. Now we take a integer like 1, like 2, like minus 1, like 3, like 4. Let's see what will happen. If a is an integer number, let's try 3 here. Try to come to 3, x goes to 3 from the positive. See, the limit will be the 3 because you are coming to 3 from the positive side. So that's the limit here. So we say the limit of the greatest integer function, x goes to a from the right, a positive from the right, it will be a itself. But if we coming to the number, the integer from the left, see, if you're coming to 3 from the left, so it will be at 2. So it will be a minus 1. So we say the limit of the greatest integer function as x goes to a does not exist if a is integer. Remember, that's a condition here. So if a is integer, the limit of the greatest integer function does not exist. The limit from the left does not equal the limit from the right. Remember these rules now. If you are coming from the positive side, the limit is a. If you are coming from the left side, the limit is a minus 1. If a is integer. Let's see now example 4. You have to study both together, example 3, example 4. Now this is the same function, greatest integer function, same question. Let's find the limit of the function here as x goes to a if a is not an integer. Now if we look at the solution of example 4, the limit of the greatest integer function if a is not integer. We take an example here like 3.5. If we are coming to 3.5 from the positive side, it's the same limit as coming to 3.5 from the negative side, from the left. So we say the limit from the right is equal limit from the left. So the limit of the greatest integer function x goes to a is equal the greatest integer of a. If a is not an integer, like 3.5, 1.6, 3.9, 4.1, etc. Now this is example 5 and the solution together. We have 4 parts here. The limit of the greatest integer function x goes to 4.7 from the positive side. So it will be the greatest integer of 4.7, which is only 4. Now, if we have a greatest, 3 is integer. Limit of the greatest integer x goes to 3 from the positive side. It's only 3 because that's the rule here. And then the limit of the greatest integer function x goes to 3 from the negative side. That's also an integer. From the negative side, it will be n minus 1. So 3 minus 1, the answer is 2. Another one here, the limit of the greatest integer, x goes to 1.1 from the negative side. It will be the greatest integer of 1.1 is equal to 1. You can remember the rules. This is example 3 and example 4. These are the rules that you need. Now let's see another 4 questions. Find the following limits if they exist. The limit of the square root of x goes to 0 from the positive, from the negative. We have another limit here, the square root of 100 minus x squared. X goes to 10 from the negative and from the positive. The first one, okay, sorry for this. The first one, the square root of x this is half parabola. This is the graph here. You know, this is half parabola in the first quadrant. So if we go, the limit of the function as the x goes to 0 from the positive side, we see the limit here is 0 because it's defined. Now here we cannot have x negative. It is not in the domain. The domain will be closed from 0 to infinity. So the limit of the square root of x does not exist as x goes to 0 from the negative side. Let's see half a circle here. Square root of 100 minus x squared, that will be half a circle. We have seen that in the algebra course. Let's look at the limit as x goes to 10 from the negative side. See, this is 10 here. You go to the 10, you are reaching 10 from the negative side. So you can replace 10 here, square it, so the answer will be 0. But if you come to 10 from the positive side, see, it will be greater than 10. Like you come from 11 and then 10.2, then 10.1. So the limit here does not exist from the positive side. Infinite limits means the limit is infinity. Infinite limit. Infinite limit means the limit is infinity. Infinite limit means the limit of the function can be plus infinity or minus infinity. If we look at this example, f of x is equal 1 over x. Let's find the limit of this function. X goes to 0 from the positive side. You know the graph of this 1 over x rational function. It will be plus infinity. If you take the limit of 1 over x, x goes to 0 from the negative side, it will be minus infinity. You can check the graph here, you see. 1 over x. Come from the positive side, see from 0 here. Come from the positive side, the function goes up. So it will be plus infinity. Come from the negative side, from the left, the graph will go down here. So it will be minus infinity. So we say the limit does not exist. Now let's take log, example 7, and the solution itself. F of x is equal log of x. This is logarithmic function base 10. Let's find the limit as x goes to 0. 0 from the positive side here. See, it goes to minus infinity. So that's minus infinity. Limit of the log of x, x goes to 0 from the negative side. Also here does not exist. Now remember, the domain of this, we have to take the argument greater than 0. The argument here is x, so domain will be from 0 open until infinity. So it is not defined on the negative numbers. This is another nice question, example 8 and the solution. The function f of x 1 over x squared. That's the graph. 1 over x squared. Remember here squared. So all the graph is positive above the x. We can observe the limit of this function 1 over x squared. X goes to 0 from the right here. See, from the right, positive. It will go to infinity, plus infinity. And the limit of this function x goes to 0 from the negative. You go this way, it will be also infinity. So we can write the limit of 1 over x squared, x goes to 0, we can write infinity. This is the same number from the right and from the left. Okay, remember here the denominator is positive, x squared. It's not like example 7. Always you can check the playlist Calculus 1 solved questions. You will find many questions there on many of the topics to learn more about these ideas. This is the end of lecture 4. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.